Hello. Let's use calculus or gamma to price a pension. So what this experiment is going to do, it's going to, well, firstly we have to derive the formula, but secondly we're going to be able to use the formula to, develop accurate results. So for example, if a 50-year-old takes a loan for a certain amount of time, at what rate should that person be loaned, or just stuff like that, which I'll show in this video. So the first thing is that we need to derive the equation. So we start with the first factor, which is the discount factor, which is, well, we're kind of setting up the whole thing, but it's e to the negative delta t. And then also what gamma comes in, it comes with the probability of death. So naturally gamma is used on a lot of these things where it could predict weather chances and stuff like that. So it's useful in cases like this where you can't be sure when someone passes away. So this subset of t of t is equal to beta to the alpha of gamma of a times t to the alpha minus 1 e to the negative beta of t. And this isn't like the beta function or anything like that, it's just the term beta. Okay, so how we can derive this or solve for this integral is that since it's with respect to t, most of this is actually a constant, except this section, t to alpha minus 1 e to the negative beta of t, but the rest of this can be considered a constant. Now what we can do is that we can combine these, so that becomes e to the negative st plus negative b of t, which is e to the negative, or e to the negative t of b plus delta, b plus delta, e to the negative b t. T to the a minus 1, which basically this is kind of a format of the gamma function, just in a specific way. So in this format, basically the formula for it, it's in the format of t to the, or n is equal to a minus 1, n minus 1, e to the negative, I believe it's kt, where k is like the constant in the front. In this case it would be b and delta, b plus delta. So that would be considered a constant. And then what we can do is that we can say equal to the gamma formula, which is gamma of n, so gamma of a over k to the n, which is b plus s, or b plus delta to the alpha. Gamma of alpha. So now what we can do is that we can solve that, and now we have to multiply by this, b alpha over gamma of alpha, and then these cross out. So it would be equal to b alpha over, b plus delta of alpha. So this is our derived formula, which, I mean, it's kind of like a sweet simplification, but this is equal to, this is kind of like the equation we're going to use. So in general, we kind of just have to assume about things and stuff. Like usually beta and gamma are assumptions on maybe like time of death or something like that. So it could be accurate, but yeah, like I said, it's more just an assumption. So let's set up an example using this. So let's just say, let's do a 40-year-old. So let's just say there's a 40-year-old. Let's just say they want to buy a life annuity. Sorry. So basically, they want let's say $30,000 a year for the rest of their life. So how much? So basically, we have to input some calculations or input some assumptions to, I guess, estimate the amount to live. So we could probably say that maybe he'll live to about 90 years old. Also, let's just say it's 4% interest. Or let's just make it 4% interest in this case. So, in this case, delta would be equal to 0.04. And then alpha, given that we think he's going to live to 90 years, alpha should be 4, and beta should be 0.08. Since the average life expected is alpha over beta, which is equal to 4 over 0.08, which is 50 years. So basically, since we derived it, we can kind of just make it simple. So our APV is equal to this equation. So our average in general is going to be equal to, in this case, 0.08 over 0.04 plus 0.08 to the fourth. So could use a calculator to solve for that. You could do 0.08 divided by 0.12, which is about 0.6 repeating, so stop at 7, and we bring that to the fourth power, which that should be about 0.9, which is equal to about 0.198. Or actually, we could just do it on simplified form, and we can convert into a fraction, which is about 16 over 81. So that's our average API. So now what? So I guess basically we just have to multiply this by the final amount. So 30,000 times 16 over 84 is equal to about $5,925. So basically, this is like, the fair amount that you want to take from the 40-year-old customer. So, like, I guess try to, like, explain it thoroughly. So, basically, at this time when they're 40 years old, they're going to give you, well, as a result, 5.9 thousand. And what you're going to do is that you're going to invest that at an average of 4%. So you will approximately have an amount to pay them $30,000 a year until they pass away. And that's kind of just how the equation works. So it can be used in a lot more than just this case. I think it's just a really useful case, especially for like companies that maybe like insurance companies. I can't be too sure, but I just think where they could recognize where they could make fair value or profit in a sense without losing customers, without losing money. So they usually probably have systems automated, but it's always cool to do it by hand. Thank you for watching my experiment.